Okay. When you're ready, then tell me. I will start this.
हाँ सर 6:33 पे स्टार्ट करते हैं सर 6:33 पे सर
Okay. Okay. No problem.
ओके ओके सर थैंक यू नंदिनी को को-होस्ट बनाइए। नंदिनी, इंट्रोडक्टरी रिमार्क प्रोसीड करिए।
Sir, am I visible and audible?
हाँ, यस, प्लीज प्रोसीड।
Hello, everyone. A very warm and lovely good evening to one and all. I am Nandini Sharma, your program coordinator. I welcome you all on 30 Days International Training Come Winter School on the topic Navigating Agriculture Transformations for the Upliftment of Rural Excellence, Nature 2024. Today is 22nd day of our training organized by AgriMeet Foundation in collaboration with CIMMYT Mexico, Southern Federal University of Russia, ICARDA Lebanon, World Agroforestry Center for International Forest Research Kenya, ICRISAT Hyderabad, Manage Hyderabad, SKLT SHU Telangana, MGUVV Durg, HAU Hisar, IGKV Raipur, IERI New Delhi, MHU Karnal, NDRI Karnal, ICAR, IERI New Delhi, ICAR, DCR Puttur Karnataka, Stanford University, and University of California. It is my great pleasure to introduce you Dr. Avinendra K. Mishra, sir, a distinguished academic and researcher whose extensive experience and expertise have contributed significantly to the fields of agricultural engineering, renewable resources, post-harvest technology, and value addition. Dr. Mishra embarked on his journey in agriculture engineering in 1988, joining the ICAR Central Institute of Agricultural Engineering in Crop Production Engineering Division. Over the years, he transitioned into post-harvest engineering, where he dedicated himself to advancing research and development. From 2010 to 2014, Dr. Mishra served as a research engineer at the College of Agriculture Engineering and Post-Harvest Technology in Gangtok, focusing on renewable energy solutions. His passion for innovation led him to take on a pivotal role at the Central Agriculture University, Imphal, where he held the position of Deputy Director of Research. Since 2023, Dr. Mishra has been serving as a professor and head at the College of Food Technology, CAU, Imphal, where he continues to push the boundaries of agriculture technology, sustainable energy, and food processing. Throughout his career, Dr. Mishra has been recognized globally for his contribution. He was honored at an international global meet in Kyrgyzstan as an organic agricultural promoter. He has authored numerous research papers and articles particularly in areas of farm mechanization, renewable energy, post-harvest engineering, and minimal processing for value addition in food system. Today, Dr. Mishra will share his insights on engineering interventions to enhance productivity, mechanization, renewable energy, and value addition with minimal processing. We are privileged to have him with us, and I'm confident that this expertise will offer valuable perspectives on advancing agricultural engineering and technology. Please join me in welcoming Dr. Avnendra K. Mishra, sir, for today's session. Over to you. The session is yours, sir. Thank you.
Thank you, Dr. Nandini, Dr. Ankur, Mr. Rohit, to give me this honor to present this presentation on mechanization, renewable energy, value additions, minimal processing, and many more. As you nicely introduced myself, I have a vast experience on different field of this agriculture engineering. So, not taking much time, I like to present my this today's presentation and brief about this my experience as I joined this very prestigious ICR Institute. This is the Central Institute of Agriculture Engineering. This is the only institute in Asia which serves on farm machinery, post-harvest engineering, drainage, and others. I have developed after joining there this one machine that is known as animal drawn reaper that we have to use to harvest different type of crops like cereals, pulses, oil seeds. Thereafter, I have joined this post-harvest engineering and technology. There we have developed too many products, different type of machines, different type of dal mills for the pulses, and we have to develop one agro processing center there in CIA Bhopal for the processing of this cereals, pulses, oil seed, spices to show as a model for agropreneurs to establish their business and earn the income by the processing of different type of things. I have served this Central Institute of Agriculture Engineering and Post-Harvest Technology under the Central Agriculture University in Gangtok in this renewable energy where we have to develop a biogas system that is suitable for the cold climate of this northeast hill regions. We have developed some insulated type of biogas plants connected with the kitchens of the farmers, different type of offices, and we have developed the dryers that is the need to reduce the consumption of valuable wood, timber wood, because in this northeast hills during winter, lot of timbers are used for the different purposes. And there, this north Gangtok, this large cardamom, it is grown, and for the drying of large cardamom, this consumption of this fuel wood is very high. So that we have developed such small dryers for this gasifier based, where we have to use less fuel. We have to develop the briquettes to reduce this fuel consumption, and we will get very good quality of this large cardamom that we have to cover under this chapter. So not taking much time, I have to start by this presentation. This is known as engineering interventions to enhance productivity through mechanization, through renewable energy, through value addition with minimal processing. As you know, our nature is blessed with 53% land suitable for cultivation versus global only 11% in India. Globally, 12% cultivated land is used to feed 17% population, and China has very less land because this is the most of the things are the hilly regions and this snow is there, and that with 9% land they have to feed 21% population. So here I show this some relations. Rice is in second position, wheat is second position, maize is seventh position, pulses is the, so 10% shares are the fruits. This is the second rank, and 9% share vegetables. So this agriculture, it is no longer a profitable position for the farmers because the inputs are expensive, the risk on farming is very high, price structure and market is volatile, global agriculture price falling or deliberately kept low, at times trapped in a bountiful syndrome, rural poverty and unemployment has increased. So these are the problem. As you have seen this, due to the climatic disturbance. As you have seen this at the time of harvesting of this paddy in the November. After harvesting, there is rain is came. So it is a big problem for the crop. So there are risks is involved always with the farming system. Since I am working in nowadays in Northeast, the Northeast regions, they consist 7 states, excluding Assam. Northeast region of India consists around 25.54 billion hectares of land resources, which comprises 8% of the total land resource of the country. 75% of these areas are hilly. About 50% of the total area falls under forest and fallow land. The fallow land can be used for energy plantation and additional source of income among the rural masses. So this is the our northeastern states. The map shows different these states, 7 states. These hilly states are known as Meghalaya, Mizoram, Manipur, Tripura, Nagaland, Arunachal Pradesh, Sikkim, and Assam. Assam is excluded with northeast regions. Okay, so here I show some this information. The topography of this northeast hill regions is the valley, plains, mid hills, high hills, alpine regions. All the this northeast region, it is having this acidic brown soils, red loamy soils, red and yellow alluvial laterite soils, and power available is 0.6 to 1.07 kilowatt per hectare. Land holdings are also very nominal. Most of the farmers have very small and marginal land holding that covers around 78.4%. The medium land holding are 20% and large is 1.5%. Under this farm power sector, the power availability that changes over 50 years. As you see in this total concern of India, this animal power or animate power is reduced from 60%. Earlier, this was too much animal power we have to use. But nowadays, this was reduced from 60% to 5%. Mechanical power are increased from 26% to 70%. Electrical motors are increased from 14% to 25%. So these are the linear relation there is with the productivity. It's a function of soil, crop, climate, rainfall, input works, efficiency of power source and utilizations, and others.
रोहित जी देखना क्या ग्लिच हो रही है, ये आवाज क्यों नहीं आ रही?
एक मिनट।
सर बोल नहीं रहे कुछ स्लाइड
नहीं, वो एक्चुअली थोड़ा सा स्लाइड मूव नहीं कर रही थी।
अच्छा
अच्छा, कोई बात नहीं, कोई बात नहीं सर।
So this agricultural mechanization, it needs high precision and energy efficient equipment and operations to save input, including power, and to increase the productivity. Constraints. What are the constraints in hill mechanization? It has the poor economy of the hill people, low land to man ratio, and fragmented land holdings. Women based agriculture and poor contribution of men in running agriculture operations. Complex and multiple farming systems. Acute problems of runoff and soil erosion. Climatic diversity within or between the farming situations. Poor fertility. Management of soil. Non-adoption of improved cropping and farming systems, inefficient agricultural tools and implements, lack of technical know-how and proper extension services, lack of organized system of marketing, migration of hilly peoples toward the plains. What are the opportunities? The opportunities in this northeast regions, this is having the good soil, having good rainfall, blessed with organic matters, labor are little cheap, and they have to work on the community basis. Organic mass used for making organic manures, fuel for the gasifiers, for the energy generation, organic farming of vegetables, fruits, flowers, orchids for the income generation, primary processing at cottage level, and for further processing with transport of raw materials. What are the challenges? Challenges are the being the hills, it is the slopy land, very small field, poor economic condition of the farmers, lack of skilled persons and knowledge, no manufacturer for agricultural and processing machines, difficult to send perishable items for long distances, poor income from the farm. In this hilly regions, the main problem is this: if your machine there is some problem or there is some part needs replacement, so you have to wait or you have to go to the nearby town or the cities, so your work will suffer. So there is a requirement to have one skilled person to for the repair of different type of machineries used in this hill regions. So now I am showing you this some the implements which we have to use in the mechanization. So this is here you see this is the machine. This is known as animal drawn puddler. This machine is used for the paddy field to puddle the soil under submerged condition to make the field for the transplantation of the rice seedlings. So this is a very small machine, and here these rotors are there, and we have to leveler is there, so we have to puddle it. Second is the hydrotiller. This is the having the same function as this animal drawn. Lightweight power tillers. These are the lightweight power tillers. By changing this backside, different type of implements. We have to work for the tillage operation. We have to work for the weeding operation. We have to work for trench making. So this is power tillers are used for different type of works. These are the power weeders, mulchers. I am not going much about this tillage. Just I am to showing is some of the implements. This is very good machine for the hills. This is the known as animal drawing inclined plate planter for the planting of the seeds like maize, peanuts, and others. Big seeds we have to plant by this machine, keeping seed to seed and plant to plant spacing as per requirement of growing. This is known as vegetable seed planters. This is known as your rice transplanter for this transplanting of paddy seedlings. This is known as 2 or 4 row paddy seeder. This is used for this direct seeding. Here we have to use this paddy seeds for direct seeding into the field, and here we have to use this paddy seedlings for the transplanting. So this machines have different type of, by changing these drums, we have to make it by 2 drums or 4 drum or 6 drum. Based on this requirement, we have to use it. So by this rotation, we have to, this drum having the seeds, these holes, and from these holes, at certain space, the seeds will fall in the line. These are the some intercultural equipments. Here you have to see this. This is the Kono weeder. This is very popular in the paddy fields for the weeding of different type of weeds in line. These are the human operated. Single man or single woman can operate this weeder, and we have to remove all the weeds in line from the paddy field. These are the power weeders. These are the different type of power weeder. Here we have to use this weeder for this groundnut field. This is the tractor operated, small tractor operated weeders. So there are number of range of different type of weeders we have to use in the field for removing of the different weeds. Here you see this harvesting. This is a unique. This is known as sickle, and this sickle has the serration. Normally, these farmers, they have to use the plain sickle. The plain sickles, the force requirement is very high. It is labor consumption is very high. The cutting of the crop by the plain sickles is less. So we have to use this modification in the sickle, having the serration. Here, sawtooth type of blades are there, hardened blade. So we have to easily cut the crop. This is known as vertical conveyor reaper. These reapers are used for harvesting of your wheat and other crop. In this system, the cutter bar is here, and this field is cutting, and this will dropping at the line this side. And here we have to make the bundles and send it to the threshing purpose. So this is for the smooth harvesting of your wheat crops and other crops. This is known as agar digger for this making of different type of holes for transplanting of different type of your plants. This machine, here we have to use this potato digger or this groundnut digger. So different type of attachment we have to use. Here it is the single blade. So with this blade, we have to harvest the potato, carrots, and others. And we have to use this serration here. So this machine is suitable for harvesting of peanuts and groundnuts also. One minute. The slides are moving very fast sometimes. Okay, this is also very good for the hills. You have seen here. This is for the sowing and planting machines. This is the seed drills and planters. So this machine is known as manual seed drill, suitable for sowing on hill slopes, terraces, and by the single man, we have to seed our different type of seeds. This is the manual mustard drill, precision vegetable drills. And this is very unique machine, single row manual drill. So this is known as precision farming. When we have to go for the precision farming, and our requirement is the seed to seed and plant to plant space should be same. There should be no variation. So this machine we have to develop. In this machine we have to place the seeds, and this is the distribution hopper. Here the seeds are distributed in this round type of disc, and from this disc metered seeds are fall inside, and this will we have to place into the row to row, plant to plant, and we have to maintain the depth also from the seeds. So this is for the manual operator, and the same machine we have to use in large scale for the precision farming by using tractors. This is known as the garlic planter. For the garlic bulb, we have to use for planting of different type of this garlic seeds into the field. This I have explained you. This is the, as you seen this in banana, northeast and other regions, banana are grown. There is a big problem after harvesting a banana, how to remove the stem, because this is deep rooted inside. So here we have to develop, this is the banana clump remover. By using this tractor, we have to remove the whole banana plant from the soil by digging up this wedge type of plow. This is the, again, this vertical conveyor reaper. This is known as the turmeric harvester. And here this is the different type of equipment we have to use for harvesting of fruits from the orchards. So some machines we have to develop by the gender specific equipments also. So here you see this gender specific for the suitable for the women's, how they have to use. So this is the only 2-row transplanter system. This is the 4-row transplanter system for the paddy. This is a small stand to remove this groundnut from the plant. So by these hooks, we have to remove all the groundnuts by this different type of wedges is there. So we have to, after harvesting groundnut, we have to remove, separate the peanuts from here. This is the fruit harvester. This is known as the weeder. This is the transplanter, drum type of transplanter. This is the fertilizer spreader. So there are different type of machine, and this machine we have to discuss later. This is the winnowing type. So here we have to clean the grain by this shaking process of this cleaner, and here with this attachment is there. So single woman or single man can clean the grains. In this there is double screen. From the top of the screen, the chaff, stones, and everything is in the top, and after filtering the size, means your suitable grain size should be dropped from this screen, and underside there is underside screen. So only dust and small immature grains fall here, and in between, in this grain cleaner, the clean grain is stored between these two sieves. Here is the gate. After this cleaning, we have to remove this, and here it is the sack holder. So we have to transfer the clean grain into the bag. So no need of the labor for the holding of bag. Here you see this for the threshing, different type of machine we have to use. This is the known as drum type of your paddy separators to remove the paddy from the paddy plants. This is the pigeon pea thresher. In this machine, we have to feed whole pigeon pea plant. This is the axial flow type. So all the parts get threshed. Stems are not crushed here, and we will get the clean pigeon pea seed from the parts by this pigeon pea threshers. This is the portable rice type of thresher. This is the groundnut thresher. As you seen there in this previous slide, the women are separating the groundnut from the groundnut plant by sitting and removing one by one. And here we have to hold the whole groundnut part, and by this machine, all the groundnut parts separated without breaking, and we will get higher efficiency of this separation of groundnut parts from the plant. So this post-harvest infrastructure, this will require post-harvest management and value addition. So in this post-harvest infrastructure, post-harvest management, it includes the harvesting, short-term storage, collection of seeds and others, plants, minimal processing, packaging, transport, and cold storage, refrigerated vans. And value addition, after harvesting, we have to go for the minimal processing, intermediate processing, ready to eat convenience foods, health foods, and food factories. So this post-harvest infrastructure, after harvesting from the field, how we have to store, how we have to harvest, how we have to go for the minimal processing and make the stuff suitable for the consumption and marketing to get extra benefit by this process. The post-harvest engineering and technology for food and nutritional security, the objectives we have to reduce post-harvest losses to food produced. As you know, there are too much losses when we have to go for harvesting some seeds that are over matured, it is fall down into the soil, or some are the under matured. So how we have to reduce the post-harvest losses? The post-harvest losses in the region is 10% to around 15-16%. To process the raw food to value-added products for the domestic use and for the exports, to generate gainful employment under this sector, to give remunerative process to farmers for their produce, and provide leadership in post-harvest engineering technology at national and international level, so that so many our graduates, undergraduates get trained and they have to go for their establishment of own business. In our college, we have given one slogan: students come as a students and go as a entrepreneurs. No need to search the job. You have to establish your own processing unit, own processing plant, and being an entrepreneur, you have to process different type of fruits, vegetables, cereals, pulses, oil seed at your own place, and you have to give employment to others. Here's little I have to highlight the production and post-harvest scenario. The agriculture contributes around 17.5% of GDP, employs 57% workforce, sustain approximately 70% of the population. India produces around 230 to 250 million tons of food grains, 53.1% and 91.6% million tons of fruits, vegetables, ranks second in the world. So these data, in our previous lecture, you have to see different lectures, these data are available. What are the reasons for the losses after harvesting or during harvesting? So this is the handling of raw produce through many stages of middlemen. Processing is mostly controlled by urban rather than rural entrepreneurs, which leads to losses in valuable byproducts, non-availability of adequate and efficient equipment, and machine to be used in catchment areas are not available. So this, our slogan is higher the value addition, means better the post-harvest management and lower will be the losses. What are the unit operations in post-harvest management? So this is for the food grains and fruits and vegetables. The food grains, as I discussed earlier, this is the harvesting at maturity, proper threshing, post-thresh cleaning, proper drying, safe storage, and fruits and vegetables. This is the pre-harvest treatment, harvesting at maturity, safe harvesting, pre-cooling and washing, surface drying, cool, cold storage, safe transport, and safe handling. The one thing is very much important in our agriculture. This temperature and humidity, or temperature and water temperature and moisture content. These are the two important factors that we have to always keep in our mind whenever we have to go for harvesting, or we have to go for storage, or we have to go for processing, or we have to go for different type of things. So this temperature and moisture content is very, very important for the safety and for the prevention of different type of losses. Now come again for this processing after harvesting and threshing from the field. How we have to clean? The major steps involved in this agricultural operation is the cleaning. That includes cleaning of the grains and different materials, sorting of the grains, and grading of the grains. So here we have to give very small and very much suitable and effective machine for the low level processing at rural levels. Either it is plain, either it is scale. So this is, as I shown you earlier, this is the hand cleaner. This is simple 4-row. We have to hang this hand cleaner from this roof, and this is the swinging type. This hand cleaner, it consists 2 screens. These screens you have to change according to your grain. For wheat, we have to use different type of screens. For the pulses, we have to use different type of screens. For oil seeds like this, your safflower, sunflower, mustard, we have to use different type of screens. So by changing these 2 screens, we have to remove the stones, chaff, and other material from the top screen, undersized material, immature grain, dust from this lower screen, and between these 2 screens, our clean grain is there. And after this cleaning, we have to remove this shutter. This is one spring-loaded handle is there, so we have to open. So this will be open, and by using this sack holder or by placing it into the drum, we have to transfer the machine, this grain, clean grain. So this is very much suitable for the cleaning. After this, there is this machine. This is known as power cum pedal operated cleaner cum dead machine. This machine have capacity of cleaning 100 to 150 kg of materials in 1 hour. So in this machine, we have to use, this is the hopper where we have to place all the grains inside, and through this lever we have to control the opening of the grains. When the grains fall here, there is this box which contains the sieves, as here. This is the top sieve, bottom sieve, and this is the lower pan. So 2 sieves we have to insert according to our requirement of the grains. And this machine consists one blower. This blower blow the air from this side, and through air all the light impurities and dust is blown off to the outside, and grain will fall inside. And here with this motor, this is checking to and fro, and by this checking we have to clean the grain. All the stones, both sides are come from this side, clean grain from goes to that side, and this immature and trash collected into the pan that will come from this side. So this machine has advantage. If you have power, you have to use very small motor run by the single phase, means your domestic. If you have power in your village, your home, you can connect it by the motor. And if you have no power, this is attached by this cycle frame. Here one cycle frame is there. With this handle, you have to sit over the seat, and by pedal you have to run this machine, and you have to clean by running this blower and this shaker. So this has advantage of with power and without power, and there is no requirement of high power requirement. You have to single phase, you have to run this. And this machine is used for the processing, means you have to clean processed product as well as raw material by using this single machine. And this cost of this machine is also not much high. This machine is around 8,000 rupees, 6 to 8,000 rupees, and this machine comes around 30 to 35,000 rupees. Another machine you show here, this is the dal mill. This is developed in CIA Bhopal. This is very simple machine, because you know the pulse processing needs a special technique to remove the hard coat from the pulses like pigeon pea, green gram, black gram, lentil, and others. So using this machine, this is a very useful machine for the processing and making the pulse into the rehearsed form of pulse or dal. So in this machine, this is the hopper. Here one carborundum roller is attached and one screen is inside. We have to feed the whole pulses from here. The scratching will take place. The husk is removed and we will get this rehearsed pulses from this end, and this rubbish or dust from this side. So this dust collected here, this is used for the animal feed, and this rehearsed pulse we have to send to this machine, and all the husk is separated by this fan, and we will get the clean separated rehearsed pulses from this grain. And some pulses which are rehearsed but not split, that we will get in the gota form, that again we have to get in the other machine and we have to split into two parts. This is another machine you have to see. This is known as peanut breaker or groundnut decorticator. So this machine is also we have to develop for the suitable for the women's as well as men. You have to work here either by standing or by sitting. So in this machine, we have to feed this groundnut, and by this to and fro motion, we have to dehusk or split the groundnut part, and we will get the dehusked pod and this peanuts here. And this again, this all dehusked part sent to this machine, and here we have to clean. This is the another. This is the same machine. You see, this is the by standing procedure you have to operate, and this is by the sitting. So you see this in Northeast, I have seen when I came here, this after harvesting, the peoples are not having such type of this very small machine. And whole family, they have to sit to break open the peanuts. And it takes lot of drudgery and lot of time to decorticate the seeds. So this machine, by using this small machine, you have to enhance the efficiency. This machine is also by this screen. We have to change this screen. So this machine is suitable for the groundnut decortication, as well as this machine is also used for the decortication of your sunflower seeds. Sunflower seed or safflower seeds for dehusking and get the inside giri by this machine. This machine has two purposes by changing this screen. This is known as groundnut decorticator or sunflower decorticator. This is the same machine I show you there, hanging type, and this is the sack holder. By this cleaning, we have to place the clean grain in this. This is another very important machine. This is known as multi-purpose bar mill, or as you know, the atta chakki. This is very small machine we have developed. So this machine has unique function which you can utilize in this hilly regions as well as plain regions for small scale processing. Having this multi-purpose grain mill and that cleaner grader, you can earn too much money by the processing. So this machine is suitable for this milling of this your grains, like this your for making wheat to wheat flour, wheat grits, maize to maize grits, maize flour. You have to split this your horse gram to make this gram dal and dehusking of this gram. And this machine is also used for the grinding of spices. You can mill your coriander seeds, turmeric by breaking by another machine. You can small pieces of turmeric you can feed that will grind. Otherwise, you have to use for the coriander, black pepper, and other purpose. So this machine is very much suitable for the low level processing. This is the washer, different type of washer we have developed for the washing of carrots, washing of this beetroots, washing of your turmeric, ginger. In this drum, you have seen this machine. In this drum, we have to feed the material which required a washing, and this container here, this is the drum which contains the water, and it is a perforated this sleeve, and we have to close this, and by rotating this drum, the carrots, potatoes, ginger, turmeric, all get washed and we have to remove from here. So this is a small machine. So after this, we have to discuss something about this soybean also. As you know, soybean is rich in protein. Soybean is not only used for the oil, it is used for the protein. And from soybean, we will get a soya milk. So this is a small cottage scale level processing plant for making soybean milk. From the milk, you have to prepare the soya paneer, soya srikhand. So many products you have to prepare by using this type of machine. So in this machine, this is the blancher to cook the soybean. This is the grinder where without oxygen we have to grind the soybean. This is the strainer to press the paneer. So this is the different type of this system we have to use. And here this machine you have to see, this is known as dehuller. This is to make the dehusking of soybean to separate their husk, and we will get the soya dal. And from this soya dal, we have to blanch it and make the soya flour. And this machine, this is known as flaker. Here we have to press this soybean, soaked soybean or this rice and make the poha. This is for making of flacking or poha making. You have to make the poha from the soybean, rice, maize, and so many things. So this is another different type of low level, cottage level processing plant for the soybean. Here you have to see this is the different products. These are developed at CIA Bhopal under our soybean processing unit. So here you see this is the soya paneer. From 1 kg of soybean, you can get around 4 liter of soya milk, and from 4 liter of this soya milk, you will get around 2 kg of this soya paneer, very good quality. So this soya paneer, the demand is very high. So by this simple plant, you have to make this soya paneer. This is the rich in protein, very good in taste, and you have to prepare different type of things. This is the full fat soya flour. By making this from this dal, we have to make the soybean flour. This is the soybean biscuit, soybean rasgulla, soybean yogurt, soybean muffins, soya srikhand, soya amrkhand. There are 120 products we have developed from the soybean milk and others. So now we have to come for cereals and grain processing. So here you see, I have shown you earlier this dal mill. From the dal mill, after this making this pulse, we have to grade. This is the grader. This is the grader, and we have to grade the pulse. The grading by size, used for size separation of pulses, cereals, gram dal, moong dal, lentil, pigeon pea, wheat. So this machine, very small machine, we have to use for the grading to grade the processed and unprocessed material from this machine. Here you see, this is, sorry. This side is not going. One minute, some problem in this. Yes. So this is known as burr mill. Burr mill, as you know, this is a common atta chakki. So these bar mills are again two types. This is the vertical, having the two stones for the grinding or milling of the different type of cereals. So this is the vertical type or horizontal type. So here the purpose of this used for milling of wheat, gram, maize, jowar and others by this using bar mill. And here we have to develop a very small machine. This is known as floor separator. So what happens with this machine, this floor separator, after milling of your wheat to wheat floor, we have to shift the wheat floor here. And this is the sieving. Under there, different type of mesh size is there. So by the sieving of this wheat floor, we have to remove the bran, means outer layer of the wheat, that is known as bran. That will come from the top. The wheat bran will come, then this is filter this wheat and we will get the wheat flour. This means the your atta, and from the third sieve we will get the fine flour, that is known as maida, and in between there is a coarse flour, that is known as suji. So from single machine, this single machine you can separate from the wheat flour to bran, wheat flour, suji and maida, four products. So flour separator for suji, maida, bran separation from the wheat flour. So this will add the value. Suppose your wheat flour is rupees 30 rupees per kg and your maida is around 60 rupees per kg. Your suji is around 50 to 60 rupees per kg. And this bran, which you have to get separated from here, it has very high value. This is in cosmetic, and for the scrubbing industry, they have the requirement of this bran. That has also very high value. So from 30 rupees product of this wheat flour, you can separate the suji of 50 to 60 rupees, maida 50 to 60 rupees, and bran. So from the same flour, you get additional benefit by using this type of flour separator. This is a pulverizer machine. That is commonly you have to know this hammer mill. So this machine has the unique machine which have a barrel which is connected by the cold water. So this micro pulverizer we have to use for the milling of spices. As you know, when we have to go for the milling of spices, or this spice have this aromatic oil, and when during milling, due to friction and grinding, the heat is generated, and due to this heat generation, the spice get burned and aroma get lost. So for the cold milling of this black pepper, cumin, and others, we have to use it. This machine we have to use for cold milling of this turmeric, peppers, and others. And this machine is also suitable for this grinding of fibrous materials like your this ginger, dry ginger, and this different type of spices, nutmeg, and your this dalchini and others. So this machine we have to use for the milling for the different type of spices and others. So this is suitable for spice contains fibrous material like ginger, turmeric, chili, cold milling, and will get the high recovery. Undersize there is screen in this machine. We have to change the screen and we will get the required size of this material. Handling, milling, and drying technology for pulses. The pulses, they have major role in our Indian food because most of the people are veg, and for the protein we have to depend upon the pulses. So this is known as major source of protein for vegetarians. Farmers' profit are very less being sold as whole. They have no such type of processing unit. So they are bound to sold their produce at very minimum price. Small scale processing at farmers level increase profit and generate employment. As I show you, this CIE dal mill has single cylinder machine. By using this machine cost is also not very high, and it will operate with single phase motor, and you have to operate 100 kg pulse in 1 hour time. So this government decided to purchase pulses direct from the farmers. A pulse is a dry legume that grows in a pod of 1 to 12 seeds. It includes lentils, beans, peas, and other little seeds. Pulses are available in three forms. This is the whole pulse, split pulse with the skin on and split pulse with the skin removed or dehusked pulses. Pulses is ground into the flour, such as gram flour from the gram dal, that is known as besan, urad flour, moong flour, and other mixes of different type of flour. So this pulse milling, processing of pulse to produce dal, means dehusked split pulse, is a unique and indigenous method of India. Pulses are dehusked particularly to improve the appearance, texture, cooking quality. The split pulses are less affected by insect pest during storage. Yield of split pulse in traditional mills is only 65 to 75% and in price to 82 to 85% potential yield. The average percentage of husk and endosperm in pigeon pea is around 15% and 85%. So this 15% is the husk and 85% is the endosperm, but we will get very less recovery by this pulse milling because we will never get this 85% recovery. We will get only 65 to 70% recovery because during this grinding some pulses get break, there is some dust form of the pulse, so recovery is very less. But that we have to improve by some improved pulse milling technologies. The status of pigeon pea, here it is shown that India is the world's largest producer of pulses and average productivity lies between 637 to 799 kg per hectare. This is the botanical name Cajanus cajan, known as red gram, pigeon pea, arahar or tuor that contains 21.7 gram protein, 1.5 gram fat, carbohydrate, dietary power, energy and others. In India, pulse milling is next to rice and white milling operation. So these units are there very less in India for the processing because of some problem. And farmers, they grow their pulses are bound to sell as a whole. So this is small scale processing can enhance the value addition on their produce and they will get good profit because suppose they have to sold the whole pulse. Suppose this pigeon pea, they have to sold at 60 to 70 rupees or 50 to 60 rupees per kg. But after processing and dehusking, the price of this pigeon pea dehusked dal is around 160 to 180 rupees. So this much benefit you will get, and additionally you will get the husk and dust. That is also you have to sold at the rate of 25 rupees or for some time it is 40 rupees per kg as a animal feed. And this the husk and this their dust they also use for the making of different type of your pellets for the food. And nowadays this our Indian Institute of Pulse Research Kanpur, they have developed a technology by this byproduct of this after this milling of these pulses, they have to sieve this dust and they have to remove the husk, and from that powder they have to make different type of biscuits, their cakes, muffins and others. So this Indian needs for pulse is 70 to 100 million tons per year. Milling losses are very high. Milling byproducts, good source of protein used as animal feed. Milling recovery is 50 to 73% depending upon the technology and machine you have to use. So this pigeon pea production in India, this figures may vary plus minus. So this Maharashtra is this 34%, UP is 14%, Orissa is 12%, Karnataka is 11%, Gujarat is 9%, Madhya Pradesh is 8%, Andhra Pradesh 7%, Bihar 5%. This data may vary. The husk, the dehulling of pigeon pea is very difficult process. Being all the pulses, this pigeon pea dehusking is very problematic and time consuming. The husk of the grain adhere to the cotyledons due to the presence of catalogous disaccharide, gluconide acid and glycol protein that adhere the skin very tight. So you are not able to remove the skin or dehusk it properly. For that we have to go for different type of treatments. So for adherence of husk to the cotyledons, albingo lacton type of polysaccharide was found responsible, which is gummy in nature and hygroscopic in nature. If you have seen this pulse, If you soak in water, it due to this gummy nature, it becomes a lump. Lump formation is there, and that is very hard. So we have to avoid this gumming and hydrophobic nature of this by the processing methods we have to use for the pulse milling. So these pre-treatments, what we have to give, we have to go for the water soaking, water spray with oil treatment, sodium bicarbonate treatment, enzyme treatment. So there are so different type of this treatment we have to use for the loosening of the seed coat or husk from the pigeon pea. The effect of chemical treatment or husk removal of pigeon pea gains using aqueous solution of calcium hydroxide, sodium bicarbonate, this others. There are some researchable issues on this pulse. This is the minimized milling losses. This is the major R&D needs nowadays. Loosening of hull and splitting technology, development of scratching mills for pulses for water absorption, drying of pre-treated soaked pulses, stable solar with hot air dryer for drying of soaked pulses, splitter for dehusking and splitting of pulses, and byproduct utilization, as I explained you, is byproduct that contain husk around 25%, powder mixed with husk, this is known as suni, husk organic dietary fiber mixed with bran for biscuits, cake, and others. Husk can be used as activated charcoal for health use, and powder, good source of protein, used as protein drink, snacks, sev, chakli, laddu, and student product. So here this husk, this is also play a very important role. Not only we have to use this husk for the animal feed, but this husk, if we have to separate this husk very clean, and after washing with this husk and clean it dust proof and others, this husk we have to use for making of bioactive charcoal under this oxygenless this pyrolysis process, and this is give you the bioactive carbon that we have to use for the different purposes on cosmetics as well as our health purpose. This is nowadays very important. This researchable skills. How do we convert this byproduct husk as a active bio charcoal? What are the present practice? Milling at farmers level, they have to, for the loosening of this husk, they have to go for roasting, soaking, splitting by traditional methods, stone milling by the chakti, split and dehusk. The dal recovery is very, very less, around 45 to 55%. Small scale milling, small dal mills, recovery is 60 to 70%. Dal milling industries, commercial practice, where they have to improve this recovery from 60 to 70%, 65 to 80%. Cleaning and grading of raw pulses, fitting operations. So there are so many processes. We have to show you the simple process of this milling of different type of pulses by using dal milling. So this is the simple process. That cleaner grader which I show you earlier, using that cleaner and grader, you have to clean and grade the pulse. Now pitting, oil mixing, conditioning, and steeping process we have to do. Then we have to go for drying. Then we have to go for the dehusking by using the dal mill, so that we will get the dal, husk, and brokens with powders. Then conditioning of unhusked and dehusked full grains. We have to go for splitting, sieving, and polishing. And then we have to go for packaging and sold. These are the dry and wet milling methods. These are the machine which I show you earlier. So for the cleaning and separation of the husk and other foreign materials, this is the dal mill. So here this dal mill, as I show you earlier, this is the simple dal mill. And nowadays we have to do advancement on this dal mill. This is the dal mill where we have to attach this cleaner cum grader also in this dal mill. So here no need to have that cleaner and grader. By this is the simple dal mill where you have see this milling is done, and we will get this dehusked pulses, and here this dust and this husk, and this after this milling this we have to send it here, and we have to clean the dal and separate the husk by the blower. And in this new machine, this cleaner grader are attached with this machine, So by this direct, we have to give the heat treatment also. We have to feed this direct from the hopper, and this after milling, this will go for the cleaning also. And this dust and husk is separated by the aspirator. So this is the new machine. This is the process. Here you show. So this after this first we have to do this whole pulse. We have to feed it into the dal mill to make it scratch. Means the skin is partially removed. We have to go for scratching, and after scratching, we have to soak this whole pulse into the water for 30 minutes in the tank. And after this 30 minutes, the skin that is soaked the water, moisture is added, and the remaining endosperm is intact. And this we have to drain this water, and we have to remove this soaked pulse. At that we have to go for drying, sun drying. So this is the process where we have to remove this water. This is the same machine. This is the drying. You see this drying. There are two methods of drying. This is the normal practice. We have to go for solar drying. We have to spread this tarpaulin, or we have to have pakka floor, and we after this soaking we have to put this dal into the drying. So what happens in summer? This is dry. The dal is get dry in 1 day or 2 days. But in winter it takes 3 to 4 days. So there is a problem came for this fungus and others. Or suppose if you have to dry this pulse after waiting, and there is rain will come, or some your this wind blow is come, and this will add the impurities and dust. So this is the tray drying we have to do, and we for that we have to develop a dryer to solve this problem. So this is the soaked pigeon pea sun drying in open field. Depends on environment. It takes 2 to 4 days time for drying. Contamination by dust, molds, and others. This is the dryer which I have developed in CIA Bhopal. So this is the hybrid dryer. So this top is the 200 micron poly sheets. During daytime, with the sun, the material get dry, and there is two gasifiers we have to use, that is burned by this briquettes or wood or some other materials, and there is two pipes inside which produce the heat inside, and due to the fan this heat is circulated around 50 to 60 degree temperature we have to maintain, and not only the day but in the night also it works. So in 1 day we will get clean environment, dry environment, drying of this pulses in this dryer. So this dryer we have developed for the drying of pulses in this during rainy season also. If rain is came, there is no problem because the pulses are placed into the tray inside this dryer. So this dryer maintains the air temperature during night and suitable for dust and contamination. This solar collector area of the dryer is around 12 square meter. The dryer unit was covered with UV stabilized 200 micron solarization sheets for intake of radiation. Gasifier stoves insulated with Insulite 13. Clay have thermal efficiency 30 plus minus 2% used for continuous heat supplement. Solar biomass dryer include dehydration chamber with 6 partition double tray racks. The forced circulation air by air maintains the air temperature uniform 55 to 70 inside the dryer during drying, and outlet fan for the exhaust of moist air from the dryer. This dryer we have developed for the drying of not only the pulses, but we have to dry any material with this type of dryer. So this some specification is given here, the dryer. This is the gasifier we have developed with the insulation material, so there is no heat loss. And in normal this stoves, the heat we will get due to the heat loss is very more, 15 to 16%. But here the heat is conserved by this insulating material, and we will get full heat. This will not heated much. We will get the efficiency of 30 to 35% with this of gasifiers. And here we have to use the briquettes made from the biomass. So this is the inside view of this tunnel dryer, where we have to place the soaked pulses in the trays, and in this area the 55-degree temperature we have to maintain, and this moisture is removed from the fan, and we will get the dry pulse. And this, after drying, we have to send these pulses to the mill again. So this husk, you see the red color, is all removed, and we will get this type of unpolished dal that is good for health. There is no polish. This demand of this unpolished dal is very, very high, and you will get the value addition. From 60 rupees raw material, you will get 150 to 160 rupees by processing of the pulses. This machine not only used for this processing of pulse of this pigeon pea, but you can process the moong dal, green gram dal, and lentil dal also. Lentil dal, their process is very simple and the efficiency is very high. You will get the gota lentil without husk and split lentil also. This dryer we have to use for the drying of different other materials, like this is the onion slices, this peas, carrot grids, so many things we can dry. And we have developed as for this hills a small dryer. This is the biomass based. In this dryer we can dry this your cardamom, ginger, potato chips, any type of green leaves. So many things we can dry with this by this small stove in the hill region. With this type of dryer, you can dry your material, and capacity of this dryer is 10 to 20 kg of material per day. And this is the other improved method of the drying. By this hot air dryer, we have to check the hot air from this stove, force the hot air into this bin. This is the sieve type of bin, and here we have to force the hot air, and through this we have to maintain the temperature also, and we have to dry the material very fast. Here this is the onion, carrot, and green peas. This is the tomato slice we have to dry in this dryer. This is the biomass dryer which I explain you. I think time is needs for hot air. These are lightweight. Drum dryers are 20 kg capacity. Portable forced hot air dryer having 50 to 100 kg capacity. Hybrid dryer with biomass and solar energy having 100 to 250 kg capacity for drying of large cardamom, ginger, turmeric, fruits, vegetable, green, and others. So here you see this in Sikkim. The problem is the drying of this large cardamom. This is the large cardamom plant. This is the large cardamom plant, and here the bulbs. We have to remove this large cardamom. This is the fresh large cardamom. And after 2-3 days, if we have not dried this, the spoilage will there, and it is too much loss. So at farmers level, they depend upon the traditional bhatti. But this dryer, which I show you, with that driver, they have to dry with very less fuel consumption within a time after harvest and separation of this large cardamom bulbs. So here this is the traditional method. Here we have to run this this bhatti by using lot of this fuel woods, and by this open tray, this is the mesh type, we have to dry the large cardamom. So this large cardamom get with this smoke, this will get black color. Here this is the some dryers which we have to use. This is the different type of dryer, large quantities of fuel wood per kg drying. These are the traditional bhattis. In Sikkim, we have to use for drying of large cardamom. This is the different type of dryers. There we have to use it. So this dryer, based on that concept, we have to develop one dryer. This is the removal of this large cardamom cliff. We have to use this type of cutter to remove this cliff from the large cardamom. This is the removal of the cliff. These cliffs we have to remove, and we have to get this large cardamom like this for the drying. So this is the initial first dryer I have developed, and based on the this success of this dryer, we have to develop that dryer. So this is, you see, the drying of this large cardamom is done here. This is the 10 to 20 kg dryer large cardamom we have to dry by using this biomass type of stove. This is the, you see the color, dry cardamom, pink natural color we will get, and black color, this is from the bhatti. And here we will get the natural color by drying this type of dryers. So this is the dryers and drying. This is the improved one of that. This is we have to use this stove after this cooking. You can use this stove for cooking, and after cooking, what are the remaining heat? you place it, and with this remaining heat, you can dry anything. Here you see, this is the drying of this turmeric rhizomes, slices and whole. Here you have to see, this is the drying of potato chips. Here drying of this ginger. And this is the drying large cardamom for the storage. These are the processed product after this, different type of machines. Here, this is the another dryer we have to use. This is used for the drying of this large cardamom, turmeric, and your this paddy. When we have to harvest the paddy, early harvest, we have to dry the paddy seed also for the low moisture content. So this capacity we can increase by the increasing or decreasing this ring. And here this blower is suck the heat from this biomass, and hot air we have to force inside this, and this material get dry. So this is the portable forced hot air dryer for hilly regions. Capacity is 100 to 150 kg. Portable concentric cylinder. Single phase hot air blower is used. Drying time is 8 to 24 hours, or with 8 to 10% moisture content. Heat biomass gasifier stove we have to use. Suitable for maize, early rice, large cardamom and others. This is the drying of this maize crops. This is the drying of these leaves. Your fenugreek leaves, you have to dry with this dryer, and you make the powder and sell it into the market. The drying of fenugreek leaves in 4-layer dryer for fenugreek powder with 500 per kg. Here you can dry any leaf, like moringa leaf or any leaf you can dry with this type of dryer at your cottage scale level. This is the ginger processing, fresh ginger, and this is the dried ginger. This is the turmeric rhizomes. This is the turmeric rhizomes and turmeric rhizome powder. This is the ginger powder, turmeric powder. This is another dryer, small scale for the drying of different type of material, including this large cardamom by the solar. This is the solar tunnel dryer, where in the rack, by this separating of the bulbs or the initial removal of the moisture content, we can use this type of dryer. So the bulbs cannot be get fungus or microorganisms should not be developed, and initially drying will take place. But this can be used for the drying, but it takes too much time. For initial moisture removal, this type of tunnel dryer we can use for the drying of large cardamom and other material. This is the stove which I have developed. This is the design development biomass stove. So this is the different type of stoves we have to develop by using the wood and briquettes and others for the cooking as well as drying purpose. This is another stove. Here we have to use this paddy husk, and we will get the very blue flame. For their stove, rice husk we have to use, or wood we have to use. Small wood chips we can use and get the heat from this type of issue. And this is also coated by the insulation, so the outer surface remains cool. This is the rice husk scope. Here we have to feed this rice husk, and around 500 gram rice. This stove will work up to 1 hour, and you have to cook. And this will, by this gasification, when the gasification, there is a blower. This is the small blower is there. With the blower, this air will pass, and this is the double wall, and this gasification will take place, and you will get the blue flame from here. And this charred husk we can use for the making of briquettes and others. So this stove is very, very useful for the rice growing hilly regions, where these husks they have to throw into the field. They have no use. So this is some other things I have given you. Why biomass? I say this biomass we have to use for the efficient drying, dehydration of agriculture produce, value addition, income generation. This rice husk we have to use for the making of this. Traditional biomass consumption in India, some chart I have given. Crop residue is 116 million tons. Fuel wood 205. Dry dung 35. So this is some data we have given how we have to use this, because your time is less. This is the briquette technology. This is also very good technology. At domestic level, you have to produce the low cost fuel material to save the fuel wood into the this hill region or other regions. So you have to make the briquettes, and that briquettes you have to use as a smokeless fuel for the burning in the different type of stoves. This is the charcoal making traditional practice in Meghalaya. They have to cut the woods, cover with the soil, and with the low oxygen they have to convert it with the wood, this wood charcoal. But this is very time consuming and there is too much loss of this fuel wood. So this is not suitable for this. To save forest, we have to stop this. This I have you develop a small kiln. This is the small kiln where this without oxygen you can burn your biomass. So with this burning, you have to fill this box and you have to burn it, and with very low this convert into the char. Here you see this is the biomass and this is the char. From different stems we will get different type of biomass. So this is the bioconversion as charcoal, and it is portable. You can use it at any place. This total weight is around 20 kg, and you can convert your all loose biomass or fuel wood, waste or other material that is having this cellulose conversion into the biocharcoal. Here you have to see this small machine, that charcoal dust we have to mix with the cow dung and this paddy husk, and we by this pressing we will get this briquettes. So this we have to make the briquette, and this briquette we have to use in place of wood charcoal in the stove. So briquettes from charcoal as smokeless fuel. So here this is the different methods of making of this. This is the rice husk. We will get the burned rice husk, and this rice husk by this pressing hand method we will get this fuel, and by this simple method we have to make this fuel by drying, and we place this as a wood to burning up into the different type of chulhas, stoves and others. So this is the machine for the making of this briquette by this power operated motor. This is having the capacity 60 to 65 kg per hour. Efficiency is 85%. Labor requirement is 2. And benefits of charcoal briquette: 1 kg charcoal briquette replaces 2.5 kg of wood required in the kitchen. The heat output is sufficient to cook the food for 4 or 5 members of the family. There is no smoke in kitchen with the use of charcoal briquettes. So this biomass dryer, as I have developed and shown you, these are the lightweight dryers. Now we come to this processing of this value addition of different type of fruits and others. So spice processing and products. Opportunities in spice processing in Northeast region. You see this large cardamom, green cardamom, turmeric, very good turmeric is here, ginger, bird eye chili, ginger and Naga chili. These are different states, and this so which state you will get this product. So this is the significance of food processing. Minimize post-harvest losses. Varieties of food products meet the consumer's demand. Employment generation, income generation, poverty, foreign exchange, export. So this all we will get by the food processing industries. Here I show you this. This is the maize cup. This is costing 10 rupees nowadays, 5 to 10 rupees. By roasting, you will get this food processing value addition of 20 rupees. And the same we have to go for puffing, we will get rupees 200. So more raw material process, more profit we will get. And this maize cup in Sikkim, they had to use lot of this jungle wood for the roasting. For that, we have to develop a suitable stove for roasting of this and reducing the wood consumption in the hills by replacing with the suitable stove and using these briquettes made from this locally, from this cow dung and this charcoal. So this I have shown you. This is the one stove I have used. This stove we have to burn this briquettes and others. This heat will develop in this outside, and we will place this butta with this maize cob inside like this, and we will get the roasting of maize cob. This will enhance the profit with very low utilization of money. So one women they can earn the money by this roasting, and with this 5 rupees or 10 rupees cob, they will get the double profit, 20 rupees. So this is another stove we have developed for this 2 to 3 cobs at a time with this type of stove, as well as this stove is used as an oven for the making of tandoori chicken and other things we can use by using maize roasting grills we have to develop. And here you see this value-added product from chilies. You have to see different type of value-added product we have to produce from the chili. Green chili in the rainy season and others, they are lost. So in this green chili, we can crush this green chili. We have to extract the juice and dry this flax. We can dry into the dryer and sold it. So we will get the double benefit by this processing of green chili. Chili paste, chili sauces we can make. This is from CFET. So this is a value-added product from chilies, chili powder, chili oleoregin, chili seed oil, chili paste, chili color, or high pungency chili oleoregins. These all we will get by the processing. Here you see this pineapple, we can dry it. This is the harvester we have developed in this Imphal. So this type of harvester we have to use for harvesting of pineapple. This rotor blade is here, and this is very suitable. By hand, we have to power operated this saw blade, and we will harvest this pineapple by using this. So this efficiency will increase. And after this harvesting, we can make the slice and dehydrate it. So this is the corer, punches, knives, accessories, utensils. I am not going in detail. You will see in my this slides. This is the vacuum drying of jackfruit bulbs because time is short. This is the process technology of bare pressure. Here we have to remove one machine we have to develop to remove the stone from the stony fruits like this bear and others. This is excellent natural color. We will get a very good texture, rich in vitamin C, rich in minerals, last enzymatic browning. So this is for this process technology of brain with this bear preserving. This is the safflower. You have to know this is also known as bird seed. So this is the safflower. This oil is very good for health. Artificial. This is also used as an artificial. This is the adulterant of the kesar. They have to use this as an adulterant in the kesar. This is the artificial kesar. This gives the color of this saffron color. Safflower tea. We have to use the safflower. It has a very medicinal value. We have to make this safflower based this toffee. Mango safflower toffee. This is the, and this is also decorticated by the same which I show you. This groundnut decorticator. Only by changing the sieve you can decorticate it, and you have to use this inside this material endosperm for making different type of product. So this is the safflower we have to process, and this is also used for the extraction of oils. So value-added product from ginger, you will get different type of this your bar mills are there. This is the bleached ginger, unbleached ginger, salted ginger, ginger preserve. So many things you can prepare by the ginger. What is the minimal processing? Now we have to discuss about the minimal processing. The minimal processing can be defined as the least possible treatment to achieve a purpose. Minimal processing method differs from conventional technologies and describes them as techniques that preserve food but also retain to a greater extent their nutritional quality and sensory characteristics by reducing the reliance on heat as the main preservation action. So here you see this minimal processes, fruits and vegetables. You have to wash it, you have to peel it, you have to cut it, dice it, and just you have to pack it and sold it. So this will give the value addition by the minimal processing. Here I show you minimal processing refers to trimming, peeling, sanctioning, slicing, pouring of fruits and vegetables. Demand for minimal processing fruits and vegetables has increased due to the busy life schedule in the cities, increased purchasing power, and health conscious trends. Now the minimal processing, you will get additional benefit from your fruits and vegetables. You have to process either harvesting from your field, either you have to buy from this wholesale market, and you have to buy it and you have to process it and you have to earn the money, additional money. So this is, I am not going further details. These are all given there. This microprocessing, how we have to do for whole product washing. We have to wash it, peel it, and do this. And these are the sorted, graded, packed, and labeled vegetables. You have seen. These are the carrot. These are, there is no need for further cleaning. Just you have to cut it and you have to use it. This is the different type of product you can process by the minimal processing. There are different type of equipments we have to use. This is the minimal processing of vegetables. These are the dryers to remove the excess water. You have to cut. This is the cabbage. You have to cut it. You have to wash it. By this, using this centrifugal dryer, you have to remove excess moisture and you have to pack it. So there are different type of this processing you can achieve by this centrifugal dryer and the cutting and dicing, peeling methods. So this is the modified atmospheric packaging for different minimally processed vegetables to retain its color, its enzyme, its quality. We have to use modified atmospheric packaging also. So this is the pumpkin. We have to clean it. We have to dice it and sold it. This is the different of products. This is the minimal processing of fruits and vegetables. You have to see here. These are some extruded products also we have to produce. Extruded products, makhana, arils, jackfruit chips, banana chips as minimal process ready to eat product. This is the makhana arils. This is very much common in this our Imphal in Manipur. This is the fresh makhana. You have to eat this puffed makhana. But here they have to use, this is the having very high thorns. So what they have to use, they have to cut it, they have to remove the arils, and they have to cook it into the curry. So this arils they have to use as a vegetable, and the seeds they have to throw. So we have developed a technology to remove these arils, and now after this collection of the seeds, we have to puff it. So this is the jackfruit, banana, so many things we can do, and we have to extruded product we can prepare. This is a map for minimum process pomegranate and arils. You can pack it and sold it. This is the aril. This is the pomegranate aril extractor. This machine is developed in Sifet, Ludhiana. High aril extraction capacity around 5 quintal per hour. Aril extraction separation efficiency is in the range of 90 to 94%. Mechanical damage received by aril is only 1 to 2%. In Hyderabad, there is one plant for this aril. They have to collect this pomegranate from this Maharashtra. They have to send it to the cool chamber. In this process, they have to remove these arils. They have to sold these arils as a fresh seeds and remain. They have to dry it. They have to make the dry this aril and they have to export to the outside of the India. So there is a very big industry they have to use for this different type of minimal processing product in Hyderabad. So with this, I thank to all participants. They have listened. They have seen the different and I have to acknowledge this ICR CIE Bhopal, CFET ICR Ludhiana, CAPST CIE Bangkok, CIU Imphal, COFT, and other organizations for this wonderful presentation. Thank you.
Thank you so much, sir. It was indeed a wonderful session, completely packed with information and knowledge. That's definitely going to help us all, both personally and professionally.
Yeah.
So, everyone, chat box is open. If you have any kind of doubt, query regarding any topic, you can freely ask. I'll be passing your question to sir. So, chat box is open. They're open. Well, we are getting the appreciation that it was a nice presentation from everyone. We have got a question that how we can get portable machines for method demonstration for farmers at our farm, Science Center, Sirohi Agriculture University, Jodhpur, Rajasthan.
Pardon?
How can we get portable machines for method demonstration for farmers at our farm, Science Center, Sirohi Agriculture University, Jodhpur, Rajasthan? We have got this question from Dr. Ankita
There are
Sharma.
number of machines we have developed in CIE Bhopal. You have to contact the director CIE Bhopal. You will get different type of machine from there. Our ATEC center is there. From there you can buy this different type of machine for the demonstration and others. Any other?
Okay. So next question is, how much temperature remain inside the solar dryer?
This is 55. I explained there. We have to maintain 55 degrees Celsius temperature inside.
Okay.
That is the recommended temperature.
Please tell the cost of minimal processing unit.
Minimum processing is depends upon this, how you have to go through. This business you can start with the minimum of 20,000 rupees to 1 lakh rupees to start your business, because there are different type of pillars required, this graters required, slicers required, and this water centrifuge to dry the excess water, and you can pack in different type of packaging material. This is the permeable methods, so that your process material should not get damaged, and you have to keep it as in ambient condition as well as in cool chambers for sale.
Okay, students are asking for the email. If you can please provide for
Yeah, you
further
can
contact.
provide this. My mail is akm.capst@gmail.com.
Okay. The same.
akm.capst, College of Agriculture Engineering and Post Harvest Technology @gmail.com.
So you can send it in the chat section. That it will be more easy.
You have this my mail. You have to send this, because this
मैं भेज दूंगा, मेरे पास है सर, मेरे पास है
my
सर की
keyboard. No, sir, there is some problem in my keyboard.
मेरे पास सर की ईमेल है, मैं भेज दूंगा, मेरे पास
This
सर
is
की ईमेल.
only they can write this AKM small में AKM Mishra का AKM dot CAEPST, College of Agriculture Engineering and Post Harvest Technology, CAEPST @gmail.com.
Okay, sir. The next question we have got, what is a drum seeder?
Drum seeder. This I have shown you there. This is used for this direct sowing of this paddy seeds. We have to fill the pre-soaked paddy seed in the drum seeder. These are the 2 drum or 4 drum, and they have the drum has the hole in the row. Now, outer periphery, there is 2 rows which have the holes. So through these holes, the paddy seed is dropped into the puddled field. So this is for direct sowing of paddy instead of your this paddy seedling.
Okay, sir. Is there any methodology or procedure for determination of crop factor for perennial fruits like mango?
This at present I am not able to give you answer.
Okay. I want to buy minimal processing setup for fruit vegetable in Jharkhand. A question by
Yeah,
Krishna.
you can start by this local, this different type of pillar. This is, you see this processors. There are different type of processors available. So for the small scale, you can use the processor, and for the large scale, they have this greater, because this slides should be more. That's why I removed that equipment from the slides. We have different type of cutters that we have to use for the cutting, different type of peelers. Like this, suppose you have to go for this removing of the peel of this potato or this carrot. So we have to drum type of washer where we have to remove the skin, and we will get this. And after this, we have to cut it into the different pieces. So there are slicers also where we have to feed this and we have to slice it. Either we have to grate it. So what, as per our need, we have to make the dice, cutting, slice, so many things we can do. So this, because this is too lengthy, already I have taken too much time. That's why I removed that slide. Any other question?
Okay. Does gasifier work like an LPG system?
No, this is not LPG. This is we have to use this gasifier where this air is sucked by the lower side, and this proper ignition is done inside this chamber, and we will get the better burning efficiency. So this gasifier, either we have to, this is the this downdraft type, where this natural air through this heat by this bottom, this goes inside, either we have to provide a small fan below this stove. So that fan force the air inside, so the proper burning is take place and gasification will take place, and we will get better efficiency of this stove. As I show you this rice husk stove. In rice husk stove, we have to use fan. So that with the fan, the air pass through this, gasification take place, and we will get the flame just like it is burning with the gas, LPG gas, blue flame you will get. And other you will get the red flame by this burning of the coke, briquette or wood pieces in the gasifier. This is known as downdraft gasifier.
Okay, sir. The next question we have got that if there is any other rather than manual solution to separate stones from the filt, is there any mechanical means of stone separation from soil? There is a big problem in using tractors and implements because of stones. The person is from Nagaland who is asking the question.
Yes, for that different type of machines are there for the separation. We have to pulverize it, and there is a screen. So after pulverization, the soil will pass through that screen. So these stones are collected on the screen that we have to separate after certain time. We have to drop it. So this all the stones get separated because these hilly regions, this is the acidic soil, and it is mostly this contains a lot of these stones. So that is a big problem. So there are machines available for this, for separation of this stone. For that, you may contact our this director CIE Bhopal. Any other question?
Okay, sir. The next question is there any technology to prevent peel browning of harvested lychee?
There is so many things we have to use. I am not go through in detail for that. This is the separate section. Oxidation and browning. Okay.
Okay, sir, that was all, and everyone is appreciating your lecture.
Okay. Thank you.
So thank you for taking out your time, and we are grateful that you came here and gave us the knowledge and information. Ankur sir, do you want to say anything?
बहुत बहुत धन्यवाद सर, इतने शॉर्ट पीरियड में आपने हमारे रिक्वेस्ट को एक्नॉलेज किया और लेक्चर को डिलीवर किया, जबकि आपको एक इम्पोर्टेंट असाइनमेंट में, एक इम्पोर्टेंट मीटिंग में जाना था, आपने मेरे कारण उसको पोस्टपोन रिशेड्यूल किया। ठीक है, तो धन्यवाद शब्द आपके लिए नहीं बनता है, बस मैं यही कहूंगा कि सहयोग और इस निवेदन को मानने के लिए बहुत बहुत धन्यवाद। आगे भी इस तरीके की एकेडमिक एक्टिविटीज में हम आपका सहयोग जरूर चाहेंगे सर।
थैंक यू डॉक्टर अंकुर।
ठीक है, थैंक यू सो मच सर। एवरीबॉडी कैन लीव। गुड नाइट। गुड नाइट।